Okay, so let's start practicing how to develop a probability distribution for different variables. And we start with example 7.1 from your textbook. So here, what are we talking about? There was a questionnaire that have been distributed on people. The objective of the questionnaire is that they want to know how many persons live in one household. So in the next slide, we're going to see what were the different answers to this question. And we want to develop a probability distribution for the variable, which is defined as the number of persons living in one household. Okay, so we can see in this table the answers that were given by 116 million people who answered our questionnaire. Let me get first my pen so that I can tell you what I'm talking about here. So what do we have here? What that 31.1 out of 116 million people who answered the questionnaire, 31.1 million answered that one person lived in the household. 38.6 million answered that two people live in the household, etc. So this table, what does it represent? In the first column, we have the number of persons. So here I can write that this column represents the values of x, okay, where x can be 1, 2, 3, 4, 5, 6. And the last one, it's a little bit tricky. Why? Because it's not one simple value, and you may have a question about this. Usually in questionnaire, when we ask a question, there can be a large number of possible answers. In order to limit the list of the answers to a certain amount, which will make our analysis in the future easier, sometimes we need to group different answers in one category, and this is what we did here. So for all those who answered 7, 8, 9, 10, etc., whatever is the number, we grouped all of these in 7 or more, and these represent 1.4 million out of the 116 million. We will take care of that later. For now, this is enough. So here we go. We have the column X, these are the possible values, and these are the observations. The question was, develop a probability distribution. What's a probability distribution? It looks like this. On the first column, you have the values of X. And remember, we are still talking about discrete variables. Like in this variable, it can take the value of the values 1, 2, 3, 4, 5, 6. So a table will be very limited for a discrete variable, and the second column will be P of X. All right. So for every value of this X, we need to find its associated probability. So what do we have here? We have the values and we have the frequencies. We don't have yet the probability, so I need to add the probability. How to find the probability? We learned from previous segments that the mostly used method to find probability is relative frequency. So P of 1, what's P of 1? P of 1 is the relative frequency, which is 31.1. Okay, number of observations who answered 1 divided by the total, which is 116, okay, which is the total number of people that were surveyed. So this will give me 0.268, and I'm showing you all the other answers. Okay, so now we have something similar to this table. Okay, this is our a probability distribution table, it looks like this, and now I have it. I have here the values of X, and here I have the associated probabilities. Okay. Now that we got the probabilities, remember we said there's a property that's very important. The sum of all the probabilities of the possible values of X should be equal to 1. So we need to do the summation, and yes, luckily here we have the value 1, which means that we did not do any mistake in the calculation above. Okay, so we're good. We have our probability distribution. A final note here before we move on and answer some question, just to be familiar with some notation. What's that 0.162? So this is P of 3, right? Because this is the probability that X is equal to 3. 0.14 is P of 4. This is 0.5, etc. Okay, so what the question here? What's the probability that there are 4 or more persons in any given household? 4 or more. So this means that this is equal to what? Equal to P of 4 plus P of 5 plus P of 6 plus P of 7 or more. Okay, so we're talking about these cases, right? These cases. And to find this probability, all what we have to do, remember the union probability, the union rule, sorry. That means I have to sum up these probabilities. Okay, so we sum these up and we get the probability that we have 4 or more. Okay, this is how we get any or we answer any question about the probability of X. Once you have the probability distribution, that's it, you get it. Okay, so the probability that 4 or more will be equal to 0.14 plus 0.062 plus 0.023 plus 0.012, and the answer will be 0.237. Okay, 0. You can do the calculation yourself. I'm going to write it down here for you. 0.237. All right, let's move on.